Hello everyone and welcome to OEM Update Magazine's interactive session on robots on Indian factories. Robotic AI and IoT adoption are automating the Indian factories. Industrial robots are taking over repetitive and hazardous tasks in factories like the automotive, electronics, including welding and material handling operation sectors in India. Smart automation helps reduce costs, machine breakdowns and errors, as well as worker injuries. There are various opportunities for intra-logistic automation solution providers to set up robotics and automation solutions for factories and warehouses. India is on move to invest in robotics and related technologies such as sensors, data analytics, 3D printing to make factories more profitable. Recently, Reliance Industries gave orders worth around $1 billion for robots with 5G technology. Trends suggest the global stock of robots from 2.25 million will multiply in the next 20 years, reaching around 20 million by 2030, with 14 million in China alone, according to the report. The edge for factories lies in robotics application. On this note, today we have come together to witness an engaging interactive session on robotics for Indian factories. Ladies and gentlemen, it's an honor and privilege for me to introduce you to today's distinguished speakers. Mr. Kalyan Ram, founder and CEO, Electrono Solutions. Mr. Anik Jain, co-founder, Gamma Skills. Mr. Naresh Kantur, Managing Director, Infosys Private Limited, and Mr. Tanmay Sharma, Senior Engineer, Business Development, BNR Industrial Automation. Let me start with Mr. Kalyan. Sir, how the collected data and data analysis helps in preventative maintenance at work floor?
Yeah, thank you so much, Krishna. I mean, it is very, very important. I think I was talking about preventive maintenance as one of the elements which helps improve the OEE. As you know, the idea of preventing something is driven by the fact that you kind of, get into a level of forecasting based on data. So, what exactly happens in the process of predicting for ensuring a preventive scenario is to facilitate the amount of data that is required for you to represent a trend. So what we do predominantly involves machine learning, obviously. That is because you collect the data across multiple operations, multiple entities. Say, suppose if you're talking about discrete manufacturing, component manufacturing across, just as a very crude example, but what I mean is, suppose you take data of production across 100 parts. So now what happens is, if you go to the maintenance parameters of the machine, we can actually start looking at a certain level of trends. So how this represents is dependent on how fine data we capture. Because if the data is not fine enough, then the trends will not represent itself or they don't repeat itself. So one needs to understand to what level of repeatability of data is needed in order to estimate the level of prediction that we are trying to assess. So when you talk about failure, there are so many elements of failure in a given machine. A lot of things can fail, right? So if we have to identify what are the key elements that we want to focus on, I think it will start with predominantly the prime movers, the heavy moving elements, rotating equipment, and so on and so forth. Rotation to transmission, motion conversion systems, and also the elements of operational failure systems, which is operator-based failures. So majority of the movements are driven by prime movers, and prime movers being electric in nature, we can actually go to very fine levels of measurements. Based on that, I'm saying that that is how the prediction can be driven, and subsequently prevention can happen.
Mr. Anik, I would like to ask you what prerequisites required for an action plan for robotizing Indian factories?
Thank you for your question, ma'am. Actually, the question that you asked actually needs a lot of time. But yes, if you see the plan that is required for automizing a particular Indian factory, if we talk about, so the modus operandi that we follow generally is the first thing we need to identify is the process that I need to identify. and what are the type of equipment I want, or what type of equipment will be suitable if I want to achieve a certain level of automation in my factory. So the most common application of automation in the industry these days is the spot welding application. So if you see any of your cars, any of the passenger cars we see, so the entire body is now made 100% by robots in company weld shops. So if we see how that actually came into picture, first of all, there was a need that there are more than 3,000 spots in a car, and it is not possible to make 800 or 1,000 cars per day using human manpower. So that was the identification is the primary, I would say, primary requirement of identification of automation is the first part. Then you need to identify the components that you need to you need to achieve that level of automation. So you need to understand if you need a 2-axis robot or a 3-axis, 4-axis, 6-axis, a gantry robot, a collaborative robot. You need PLCs, you need what is the electrical architecture that you need to follow. Do you need hardwiring, you need Ethernet, device net, and what are the mechanical devices then will be required. So all those things will eventually sum up to make your concept plan for automation. And then you will also have the level of maintenance required, because then you have to simplify the system, because you ultimately have to maintain your system. And then coming down to the point that Mr. Kalyaram also mentioned, that now the next level to that would be IoT, getting out data from your machine. So you cannot only have preventive maintenance, but you also need to have predictive maintenance. You need to know when your machine is going to fail, so that you can plan for that and your efficiency does not go down. So yes, I would feel identification of the need, then the components required, then how to make that, how to achieve a proper handshaking of those equipments, and what all are the future requirements from that particular system. So that would be required to automate a particular process in the main factory, or any factory for that matter. Thank you.
That's precise. You spoke about skill upgradation in your submission. Can you suggest few measures as well?
I feel since I grew up, there was nobody to tell me this, but there's something that I realized for skill upgradation. I think the one key factor that people need to keep in mind is to learn a particular thing by keeping the application in their minds. What we do is we just keep on learning, and we whenever we learn the second thing, we tend to forget the first thing because we've never applied it in our life. You will get people telling you that I've never used trigonometry in my entire life. I've never used a binomial theorem, or I've never used differentiation, integration. But if you come to the engineering sector, you will be using these theorems. You will be using trigonometry. I use trigonometry every day in my robotics life. The applications that I work on, to program a robot, I need to calculate the angles, I need to calculate the hypotenuse, side length. So I do use trigonometry, and I know the way these things are being used. So I would say the primary way to develop your skills is to apply what you are learning. Rest everything will follow.
Mr. Naresh, Mr. Parag Panchal asks, interesting comparisons of cobot versus robot. However, why playback period is very high for cobot in India? That is, what are the factors affecting playback period?
Robot versus cobot debate is a very long debate nowadays. Means ever since we started working on cobots for last 5-6 years, this debate is going on. Whether cobots are expensive? Yes, gentleman is right in asking this question. Robots are cheaper? Yes, that is also the right statement. And based on my personal experience of having implemented 200 robots, both in automotive and FMCG and food and various different type of industry, what we have seen that at the end of the day, what we have to check is ROI, not only based on the labor or worker which has been raised, compared to the calculation of the ROI based on what productivity increase you are going to do, what are the energy savings you are going to do, and what are the flexibility you are going to build in. Once we look into these parameters, we find that robot versus cobot debate immediately gets over, because end of the day we have to work with the latest technology, and latest technology in the industry is cobots. Yes, there have been some limitations as far as the payload capacity of the cobots are concerned. They started with 3 kg, 5 kg, then came to 10 kg, 16 kg, 20 kg. And Ankit, being a Fanuc background, who know that Fanuc also has a 35 kg cobot now available. Energy cost saving per se itself is good enough to nullify the complete cost of extra that you pay onto the collaborative robot compared to robots. Like 3 kilowatt of a 3-phase 10 kg payload robot, if ABB or Fanuc, any of them, and versus 10 kg collaborative robot is going to consume, nobody will believe, 200 watt flat. So 3 kilowatt versus 200 watt, an amount of energy you save per day. In 2 years, you will recover the complete cost of excess money that you are paying in the cobot. Second biggest advantage for cost calculation is that collaborative robot occupies a space which is less than half of what human being will occupy. Forget about robot. Whereas in the same place, when you want to put a robot, you got to have a large space, maybe 9 square meter or 10 square meter in a space. And for deploying a cobot, what I am talking about is a 100 millimeter square pipe. That is good enough. And nowadays, real estate and space is mind-boggling. You know, in any industry, anybody is struggling nowadays in a space. So if you put all these parameters together, you will find that cobots are cheaper as far as the cost of ownership or implementation is concerned. That is my take.
Mr. Tanmay, how AI will reduce the complexity of managing robots and machines in different ecosystems? Do we need a standard code of conduct for robotization?
What I generally feel in terms of AI, this cost involved in this particular field is not as important as how much flexibility we can get with AI plus robotics. So where in industry we are talking about digital twin as a technology plus robotics is also going on right now. So if we club these two, the flexibility what we get is huge. Before implementing the solution, we can try and test our system, and we can check the efficiency, we can check the problems which we are going to face in the future for the solution what we are providing. So the integration of these two can prove to be very valuable and will unfold different levels of robotics.
Mr. Kalyan, Pulkit Mathur wants to know, what is silo level and connection with OEE?
The objective of having a silo is to store raw material, right? So observing the consumption of raw material from a silo is going to also translate into what is the amount of parts being produced. Because ultimately, if you take estimation of the raw material consumed versus the finished goods delivered, the only difference will be the wastage involved. So if we if we really want to look at the number of parts produced and correlate with respect to the silo raw material, then we can actually assess what is the amount of waste involved in the system. By knowing the waste involved, it is very important, because ultimately efficiency is also a function of waste, right? I mean, the idea is to minimize the waste. So in that context, we can, with this information, we can go back and tweak our systems, improve our equipment, identify the root causes of wastage and eliminate wastage if possible. Alternatively, it can also be used to validate the amount of parts produced versus the raw materials consumed to ensure that your computational framework is meeting the necessary criteria to ensure you have the right OEE being calculated. The question here is, when I say I calculated OEE, how do you justify that this computation of OEE is valid, is repeatable, is sustainable? So that is where all these questions come from. So, and for that, we need to have multiple references for validating the OEE computation, and measuring the silo levels would be one of them. Subsequently, as we have been talking about several, as a corollary example I can give you is, imagine an operator operating a machine versus a robot operating a machine. So now when you say what is the impact on OEE, here we are trying to increase the availability. as a factor, because robot will help replace the availability factor of the individual, and that is going to enhance the OEE. So the idea is to have a validated OEE having multiple reference points. So Sila will be a very interesting and important.
Mr. Anik, is the robots manufacturing going on lines of self-reliance in our country?
Definitely. The robot manufacturing that is happening right now, as I mentioned, that due to COVID, the rate of adoption and the rate of adoption of automation in our country has increased manifold. And yes, we are seeing the manufacturing of robots within India. I won't say the manufacturing of robots in India is quite on a large scale, or I would say the industrial robots that are used in India nowadays are not being made within India. They're mostly made by Japanese or European manufacturers. But robots in itself is a very broad term, and we as automation and industrial robotics people, we would say that yes, industrial robots is not something that is being made in India very on a large scale. But if we talk about the robots, such as we talk about drones, we talk about the warehouse automation robots, we talk about home automation that is being done these days. Yes, India is very much into all this. But yes, industrial robots something that industrial robots is something that where Indian is not manufacturing that much these days, as of now, I would say.
Mr. Tanmay, Mr. Parag asks, very nice concept for single control for automation and robot. Any application reference with respect to arc welding application? Please respond.
Okay. Okay. So arc welding is an application which I think is involved in a lot of industries. Right now we are in phase of developing developing and a lot of solutions around this field of mechanical solutions like welding, painting, and all these things. Right now in India, there are no direct examples I can share with you right now. Maybe on a global level, there might be some solutions which I'll be very happy to share with the users if connected online. So maybe if you can share with me the email ID of the person, I'll be very happy to share the solution. But right now, we are mostly in the development phase.
Mr. Naresh, how to make sure workflows with robots or cobots are safer and resistant to hacks? There can be unpredictable conditions at work where usually humans make decisions, right?
Yes, it's a very difficult question to answer. How difficult or easy it is to hack. Now that is a philosophy which is true with any electronic devices. It can go comfortably, but nowadays the network security which is being provided to all the devices is going high, and so far all these devices are being kept into a private network, so possibilities are least unless we hit across the places or the technology where they're able to connect it to unconnected devices. So that way, at the moment, it sounds difficult, but subsequently there are good chances that securities have to be built in to avoid that. And there was another question in the chat that is there any application which robots cannot do, only cobot can do? If you permit, I would like to answer that.
Sure, sir.
Yes. Anything that robot does, cobot also can do, or whatever cobot can do, robot also can do. But there are certain applications where industrial robot may not find it easy to be done. For example, physiotherapy in a hospital environment, or for that matter, a robot assisting a doctor into the surgery. You need a very precise control and very precise maneuvering where they doesn't hurt. So there are few applications where only cobot will be able to handle it, but not the robot. Thank you.
Thank you, Mr. Naresh. This panel discussion was very interesting and knowledge sharing. It was a privilege to host experts like you all today. Even we had a very interactive delegates today. We still got many questions that are not addressed due to timeline. Now, can I request Mr. Kalyan Ram to give a closing statement for this session?
Thank you so much, Krishna. Once again, thank you all. It was wonderful hearing to co-panelists, starting with Anikji, Naresh. We all know each other for a while now, so it was wonderful to catch up again with all of you here. And thanks so much for all the for all the participants today. It is indeed great to be a part of this session. And again, once again, thanks to Anup Wadhwaji and the Automation Industries Association, which we are all a part of. So, as a closing remark, I would say that the evolution of technology has been based on the kind of needs that drive our society. I think this is consistent whether we talk about the nature of implementation of all forms of technology that we use today is all defined by a need. So this level of need varies from organization to organization, individuals to individuals in the process of developing a given outcome or solution. So I would at this point suggest that all of us might have to reassess our needs and rethink on what and recalibrate our definition of need for a superior outcome and a superior manufacturing capability. And when we do that, we will then notice that why all these have evolved in a certain way. While we know that this industry 4.0 as a 4.0 is coined much recently, and then all the 3.0, 2.0, and 1.0 is also coined in retrospective. But the idea is why this has evolved, what is happening today, and what is going to be the future of all of this is determined by redefining the need. So benchmarking the need to a higher level will help us to utilize the technology much better. Like what Anik also mentioned, I know that I have also come across this thing that most of them say that out of the amount of mathematics that we have learned in the process of finishing our engineering degree, most of them claim that you wouldn't be even using 1 or 2% of it. But today I can confidently tell you all the participants and specifically students if they're around, that if you are getting into the next level of manufacturing, automation, and digital transformation up to the digital twin that is anticipated, I can guarantee you that you will be using more than 90% of every page of mathematics that you have ever learned in your life, because it is really exciting and interesting in that context. And we use it a lot, like what Anik mentioned. We use a lot of calculus, differential equations, difference equations, and all of that. So with that, all the best to all of us. Thank you.
Thank you, panelists, for exchanging your valuable thoughts on today's topic, robots for Indian factories. We hope you enjoyed the session thoroughly. Before wrapping up today's session, we would like to thank our distinguished panelists, Mr. Naresh, Mr. Tanmay, Mr. Anik, and Mr. Kalyan. Once again, I thank Mr. Anup Wadhwa and Automation Industry Association to support this session as a knowledge partner. I would also like to thank Mr. Gopal Anand and Mr. Prasad Nair for taking this initiative. We would like our delegates and viewers to stay connected with us on our social media handles. OEM Update Magazine is available on Facebook, Twitter, and Instagram. Additionally, you can also download our app from Google Play and App Store. So with this, we would like to announce the closing of today's session. Request you to stay tuned for such sessions. Thank you and goodbye.